Test is going to still be on Wednesday. Vectors and navigation. We will be collecting the 6 word problems from the 4-mod day and the purple packet. So it's either a green or yellow sheet depending on what time of the day you had it in, and then it's the purple packet. Okay. All right. So make sure that those are done and ready to go. All right. Today we're going to talk inclined ramps. Okay, and how those work on with forces and all that fun stuff. Okay, so there are 3 forces at work when. So, like, let's say your car. I got to think of when. So you're going up Ridge Street right out here. Okay, and you got stopped at that light. Okay, so now you're on an inclined ramp. Okay. There's 3 forces at work on your vehicle at that point in time. The first force is something called the normal force. Let's actually go like this. I want that one, and I want that one, and I want it to be that one. Oops, that's not blue. Okay. Yeah, I would be drawing this, yes. Okay. So the normal force is perpendicular to the surface. Another force working on your object. Oops, that one should go down a little bit. Another force working on your object is friction. Friction is parallel to your surface. Still not quite parallel. It's actually pretty close. Okay. What's the other one? Gravity. Yep. Gravity's coming into play here. Now, if I manipulate those 3 forces, and I say that they all, make it so that I can see it, that they all come out of the same spot, okay, then what's neat here is if I bring that down, let me move gravity here. If I bring that down, then I get a nice little triangle in there. And the nice part about that triangle is that whatever angle your ramp is inclined, that is the same as this angle right there. When we're dealing with the forces, gravity plus friction plus my normal force has to cancel out if my object is at rest. If my object's not at rest, then they don't cancel out. But if my object is at rest, all three of those forces added together cancel each other out. Now, you are going to want to, I don't know if I want to say memorize this, but for these inclined ramp problems, this is always going to be a right angle because my normal force is always perpendicular to my surface, which is my friction force, and gravity is always there. Orange yet. And so then if this is theta, then that is theta. Let's put it to work. A 58-pound object is at rest on a ramp with an inclined angle of 16 degrees. Find the friction force, find the normal force. No, that's bad. We'll just start over again. Yeah, hairball. Right? So that's my picture that I start out with for all my inclined forces once. Okay? My inclined angle is 16 degrees, which makes that angle in my triangle 16 degrees. Gravity is the weight that that's holding you down. So gravity here is going to be 58 pounds. My normal force is there. My frictional force is there. How am I going to solve for my normal force and my frictional force? What? Right triangle trig, yeah. And which one you want to do first? Normal first? So if I'm doing normal, what am I going to use? Cosine? Oops, not by 16. Normal divided by 58. I get 55.732 is my normal force. 7.532. Sine then. Yes'm? You try this one. Just cause. But not today. So there's my right angle. 50-degree angle there, which makes this a 50-degree angle there. 120 pounds is my gravity. Normal there, friction there.
It honestly was.
Magnitude or from vector? Yeah.
He said it was the best part about the video, and he was right.
Yeah. So the cosine of 50 is the normal over 120. Sine of 50 is friction. Yes'm? Friction's 91.92, or really 93, and normal is 77.13. Yeah? Love it. Love it. All right. Multiple forces.
Oh no.
Yeah. So if I got a ball, okay, and I got two forces acting on this ball, okay, what are the options that can happen to this ball if I got two forces working on this ball? It could go straight up. It could go this way. Could go that way. Could go that way. Yeah, take it off the projector. Yeah, not a good plan. Okay? All right? So, depending upon which force is more, it could go that way, it could go that way, or it could go that way. All right? So, if an object, if three forces with magnitudes of 70, 40, and 60 pounds act on an object of angles of negative 30 degrees, 45 degrees, and 135 degrees, find the magnitude and direction of the result of these forces. Okay, well, so you've got three forces working on a ball, right? So let's call the first force U. Should be the, like, it's on one of the pages before navigation.
It's right after number 10.
Yeah, it's in the green packet. I know it is.
I think it's the last question.
It has the wrong numbers though.
70, 40, and 60. Yeah, it's there.
I was looking at
Oh, yeah, wrong one. Yeah, it's there. Okay, we jumped around a little bit. Yeah. Okay. All right. So the first force has a magnitude of 70, and it acts on it at an angle of negative 30 degrees. It's in there, I promise.
No, but there's no, like, with the exact numbers.
Oh, okay. So force U, the first force, has a vector, if you will, of 60.6218, comma, negative 35. The second force has a 40 magnitude and a angle of 45 degrees. So that gives me a vector of 28.2843, comma 28.2843. Third force, magnitude of 60, angle of 135. Gets me that.
That's supposed to be sine.
Oh, yep, good call. So what's the result going to be? What am I going to do with my three forces? I'm going to add them all up together. Yep. Okay. So the result bless you. So if I add all of those together, I get 46.4796 and 35.7107. We want to know the magnitude and direction of that force. How am I going to find the magnitude of that resultant force? Love it. Let's do it. I get the resultant force is 58.6141 pounds. Yes? Which quadrant is my resultant force in? It's in 1, right? So my direction angle is going to be my reference angle. So I get that my direction angle is 37.5354 degrees. Okay? One last thing here in the last minute or so of class. On this problem, okay, which is the one that we didn't do navigation-wise yesterday. The kicker here is that the wind is from that direction, which means it's blowing to 180 degrees beyond that. Okay? So if the wind is from the north, that means that the wind is blowing south. If the wind is from the east, that means it's blowing to the west. Okay? We wanted to tell you that just in case you tried some of those problems in the the purple packet this weekend. Test is on Wednesday.